Hi, my name is Nicholas Wagner. I am the math instructional coach for the Barney Charter School Initiative. I just did a video on the BCSI approach to math instruction and what we look for in a classical math instruction, math class. And now we're going to take a look at Singaporean techniques. Before we get into that, I'm going to talk a little bit about the story of Singapore. In the late 1980s, the country, or the nation-state of Singapore, held a summit and concluded that since their city-state did not have as many natural resources, one of the things that they were going to focus on was the development of the intellectual capacity of their children. The government of Singapore decided that they wanted to revamp their educational system. So when they did that, they were operating under two guiding principles. One, they wanted to raise standards. And two, they wanted to change the language of instruction to English. Okay, these two things I think are particularly helpful for our purposes, or for what we're using Singapore math for. By raising the standards, they were very intentional. They didn't just push algebraic concepts lower. They were really trying to figure out what students could handle at lower levels. So a lot of math curriculum in America today might argue that theirs is advanced, and I think that that's probably accurate. But the question is, how intentional were they to make sure that it matches up with the development of the students' abilities? So raising standards was very important. And the second point is especially important too. The changing the language of instruction to English means that they had a whole bunch of English language learner students. They had students who were less familiar with learning in that language. So they've designed it in such a way that the students who are ELLs may have an easier time understanding the math instruction. So there were three people, three key researchers that influenced Singaporean instruction in mathematics. And those three people were Jerome Bruner, Zoltan Dean, and Richard Skimp. So Jerome Bruner may have had the biggest impact because he believes that there are phases of intellectual development. We learn in phases, and those phases that Singapore highlights are these three, the ones that are foundational to Singapore instruction. That is, going through the concrete to the pictorial to the abstract. So some schools have done this really well in the past, not as many as I think would benefit from it. Then this step right here has been added, and I don't think many schools in the past have used the pictorial after the concrete to get to the abstract. So kids in some classes may be familiar with using the manipulatives, but then they jump too quickly to the abstract. Then there's Zoltan Dean's. Zoltan Dean's. And he has the mathematical variability principle attributed to him. Sorry. Again, that's the mathematical variability principle. And what that is saying is for you to really understand something, you have to see it in multiple ways. So again, this concrete, pictorial, abstract, that would be true. You're seeing it in 3 different ways. Another thing to think about is when students are using manipulatives, especially in kindergarten when they're trying to learn numbers attached to physical items, if you only ever give them the counting bears or the attribute bears, they're going to see only one type of thing that they're counting. And so they might just assume, this isn't going to be true always, but they might assume that the only things that those numbers can be attributed to are those counting bears. So it's nice to also incorporate a variety of types of manipulatives so that they see, okay, numbers don't just apply to this one thing. They see it in a variety of forms. And then the third person is Richard Skimp. And Richard Skimp really focuses on the balance between the relational understanding and procedural knowledge. So there's a balance between relational understanding and procedural knowledge. Okay, and what that is meaning is relational understanding is really the development of the idea of why we do something. Why do we in long division start in the highest place value when in the other operations we start in the lowest place value, for example. Mixing that, you have to have a balance between that, the conceptual, so why. This is why we do something, okay, and then the procedural, which would be how we do something. So going through the steps, what processes do we actually walk through in order to do it? You can't just do it, though. You also have to understand it. So this is the why we do something, and this is how we do it, or these are the steps that you would do. So what we try to do, and what Singapore has done, is tried to marry the concept with the procedure. So students aren't just going through a rote set of steps, but they're really understanding why those steps work. Going back to the concrete, pictorial, and abstract, which you'll often hear referenced as CPA, if you ever see that in a Singapore text. The CPA approach, or the concrete to pictorial to abstract. This is where we're going to use manipulatives. So we'll use those little counting bears. I like to say that we have apples, for example. Not the best at drawing. So we have a drawing that is on box that you can reference if you're going to do a training on this. But and then you can have, say, a lemon. It looks more like a pomegranate. So this would be 2 plus 1, right? And then you would combine those things maybe and say that's 2 apples and 1 lemon make 3 fruit. Then we would go to, say, the pictorial, where we would say 2 apples and a lemon equals 3. 2. So this would be more of what we would call a bar model, and we'll get to that a little bit later. To then the abstract, the 2 plus 1 equals 3. Bar models don't necessarily look like this, but just to give you kind of the reference of a pictorial. So you'd go from the concrete physical items to two pictures to then to the abstract. Again, this is not a bar model reference, so don't think that That's the way that you draw them. Beyond that, a few other hallmarks of Singapore curriculum is that problem solving lies at the core. Problem solving is important. Again, I've already touched on this on what I'm looking for in a classical math classroom anyways, but I think it's worth repeating. Number sense and mental arithmetic. Okay, and then we have the three big things that Singapore focuses on, and I'm going to list those out right here, just to highlight them especially. Number bonds. Ooh, that's poorly written. Number bonds. And then they emphasize place value. And then lastly, bar modeling, which is getting into the visual approach. Actually, all number bonds and bar models are pretty visual approach. Okay, so number bonds, place value, and bar modeling. The materials that Singapore uses are really designed so that there aren't many distractions. A lot of times we see in curriculum today, a kid's playing basketball in the textbook, and you're wondering, what does that basketball player have to do with what we're covering right now? So whatever is in the text for the primary mathematics or the dimensions textbooks that we recommend, those are very intentional, they're very purposeful, and they should be there. And so maybe when you're going through the teacher's guide, look for why are those things in there. And the other thing that it does, that Singapore does, is it spirals from year to year. It's not going to spiral in quite the same way that you would say maybe Saxon math spirals, where Saxon math pulls in lessons from earlier, pulls in material from earlier lessons and incorporates that into the homework. Singapore doesn't do that as much. What they do is year over year they have a flow. So you'll see fractions in third grade, fractions in fourth grade, fractions in fifth grade again, and it's a continued development from year to year. So on that note, I think it's important, worth noting that you should, as a teacher, be incorporating old homework problems into the homework that you're assigning, so that the students are getting exposed to the old stuff and not forgetting those things. Going back to the conceptual and the procedural being married, tied together, they're less likely to just forget what they learned. However, I still think that there's value in actually doing some of that spiraling like Saxon math does for them. And I've already hit on this, but it's supposed to be a more advanced curriculum. In the last video that I did, there's another piece that I mentioned already to you, but I think, again, is worth highlighting. You do not want to have students seeing problems always in the same way. And Singapore does a really good job of approaching problems from a variety of directions. The example that I gave is that we're used to seeing 3 plus 4 equals 5 plus 2 equals 9 plus 11 equals, and so on and so forth. Instead, we want you to do something like 3 plus blank equals 7, blank plus 2 equals 7, and continue that on. Or 9 plus blank equals 20. You get the idea. So changing up the way that the problem is worded so that the students will be exposed to it in a variety of ways. A note on that, many states in their state test for mathematics are actually incorporating problems that look more like this. And what this does is it develops a deeper understanding, or at least it's testing for a deeper understanding of what is happening in this problem. When we get to talk about number bonds, giving problems in a variety of ways with number bonds like this, giving problems like this are more manageable. So the students aren't as freaked out by being given problems in this way. Singapore Math has a diagram, or there's a framework that they use, and you'll see that framework in the form of a pentagon. And it's really meant for problem solving. I'm not going to recreate that here for you. But when you see this, it's in the textbooks. And in the teacher's guides, actually. It's in the teacher's guides. But their framework for mathematics incorporates things that I think highlights a few qualities that I really want to focus on. One is there's this element of metacognition, and it's the ability for students to monitor their own thinking, and I think that ties in well with what I said in the last video, where it says when they say that they're able to know if they're on the right track or not. They can tell through number sense, through the development of number sense, whether they're going towards the answer or not going towards the answer. The other piece that I think, so metacognition is here. Then on the same framework, there's processes. On processes, I would say communication is the piece that I'd like to highlight. Communication, what I think of when I see that on this is the ability to explain things. And so again, using good questions, you're going to draw out explanations, and they have to be able to communicate those concepts, those ideas to you. A few other things. Attitudes is going to be on this piece right here. And the attitudes, really the thing that I think is most important, I've already highlighted in the last video, confidence, the confidence to approach a problem, but also perseverance. So part of our curriculum is, actually a large part of our curriculum, is the development of virtue. And I think courage and perseverance are two virtues that are really well developed in mathematics, and in particular in Singapore math, which relies heavily on problem solving. The courage to try something or to face the problem is significant. And then also to push through a problem, to be incorrect, and continue to try to solve the problem even though you've made a mistake. And then also to finish all the way through to the end of the problem, to find the solution after a long period of time. So allowing students to struggle is a good thing. That's okay. I ask that you reference that framework on your own time. I'm not going to redraw that for you. So I want to talk about now, why did we choose Singapore Math? I think that's probably a big question that's on many teachers' minds. And the reason we chose Singapore Math is that, one, it's been internationally recognized by the TEMS education test, and that is the trends in mathematics and science, where they test 4th and 8th graders to see how they're performing internationally. And they've been at the top for I think about the last 20 years. And so they have a proven track record. And then the other reason that we've chosen Singapore Math is we wanted a curriculum that developed the conceptual really well, even though it doesn't work on the procedural fluency as much as some other programs. So in the past, I think we may have used Saxon for some things, Saxon Math, which does the procedural really well. But instead, we want to focus for our teachers and for our students on a curriculum that has that conceptual, that concept-based approach done really well, because it's easier to support, or rather supplement, the concept-based curriculum with more practice problems than it is to develop the conceptual out of a procedural or practice-based curriculum. So that's really the reason we've chosen the Singapore curriculum. There are a few issues that have happened in America and in the adoption of Singapore curriculum, which I think have been largely addressed by both Hillsdale's instruction in the past few years and trainings that we do for you, but also by Dimensions Math. Dimensions Math has been specifically designed for teachers. It's been designed for American teachers, where it lays out in very plain language what in each lesson you're trying to focus on. In Singapore, they spend about 1 to 2 years in math training and in math education training. And obviously, that's not happening in Singapore training in America. There's not a program. I think there are some programs that are being developed for that, but currently there isn't a program that we offer or that is readily available to teachers to get that training. So Dimensions Math separates each lesson into its own distinct qualities and says these are the things that you need to highlight in that lesson. So they've done a really good job of building a curriculum that is designed for the American teacher. So really, to complete this diagram that I have drawn, we started with the classical pedagogy piece, and I said we were going to be talking about Singaporean techniques. And there I want to highlight two pieces. The first is, again, the pictorial approach that is very specific to Singapore. And then the other piece is the number sense and problem solving emphasis. So that's really it for the Singapore training. Please join me for a talk on number bonds. Thank you very much.